Okay, now we have some problems where they're asking us to write whether the number is rational, irrational, or not a real number. First, we should talk about what that means. A rational number is any number that can be written as a fraction. That includes decimals, but not necessarily decimals that don't terminate, I guess you would say. Repeating decimals usually can be written as a fraction, but there are numbers out there that exist, but we can't write them as a fraction. Pi would be a good example of that you may be familiar with. Another example is many square roots. Now, if a number is a perfect square, like number 43 here, the square root of 25 is 5, right? If it's a perfect square, then the number is rational. Now, let's see if I can write that so it looks like we're saying rational. Okay, I need to calibrate this thing one of these days. Okay, on the other hand, the square root of 29. So it happens that 29 is a perfect, 29 is prime. So we can't even simplify it. But even radicals that can be simplified, if they're not a perfect square, the number's irrational. Now, how about the negative of the square root of 64? Well, 64 is a perfect square, right? So this would equal the negative of 8. That can be expressed as a fraction, so yes, it is rational. So, what would be an example of one that's not a real number? Anything with a negative inside the radical. Let's say we had the square root of negative 64. Well, the square root means that if we take this number and multiply it by itself, if we square it, we're going to get what's inside. So is there any number that we can square and get a negative number? Let's take negative 8, because the square root of 64 was 8. So if we take negative 8 and we square it, do we get negative 64? No, we get positive 64. It's not possible to square a number and get a negative number. So if the negative is inside of the square root sign, if it's inside of the radical, then we have not a real number. Now, we do have numbers called imaginary numbers. They're tools that we've invented for dealing with these to make unsolvable problems solvable, but you won't deal with those until you get to Algebra 2. So for our purposes, the answer here is going to be not a real number. But that's only if you find a problem where they give you a negative inside of the square root symbol, inside of, well, it has to be square root or another even root. With cube roots, we can deal with negative numbers. So if it's a square root, and the negative is inside of the square root symbol, then it's not a real number.